video, we'll be looking at a critical thinking problem based on probability. Let's look at it. There are a stack of cards numbered within the range of 2 to 20. The cards are as given below: 2, 4, 5, 8, 12, 16 and 20. From these cards, 4 cards are selected at random without any replacement. What is the probability that the sum of the 4 cards numbers is divisible by 4? Okay, so we have a stack of cards. It's numbered 2, 4, 5, 8, 12, 16 and 20. Okay, so from these cards, we are selecting 4 cards at random without any replacement. So let's just say I'm choosing 4 cards. I could take 2 and then randomly I could take 5 next without replacing 12 and 16. So I have these 4 cards. They want you to find out the probability that the sum of these 4 cards numbers is divisible by 4. So you have to find out the probability that this sum is 30, 35, 37. It's not divisible by 4. So you have to find out the probability that if I choose any 4 of these at random without any replacement, it will be divisible by 4. Without any replacement means I cannot have 2 of one number. I can't have 5, 5, 12, 18. There can be no repetition. Okay. So now let's proceed with the problem. Now the formula for any probability question is number of desired outcomes divided by total number of outcomes. So we'll be first looking at total number of outcomes. How do you find out the total number of outcomes? You are choosing 4 cards out of all of these cards. First, let's look at how many cards there are. There are 7 cards. So you're choosing 4 out of 7 randomly. So the order does not matter. We'll be using combination. Out of 7, you're choosing 4. So we'll take 7 factorial by 4 factorial, 3 factorial. As you know, this is the formula for combination. It is n factorial by n minus r whole factorial and r factorial. Okay, on solving this, we will get 35. If you want to know how to solve it, I'll solve it really quickly. We have 7 into 6 into 5 into 4 factorial. Down here we have 4 factorial. These two get cancelled. 3 into 2. That's 3 factorial. 35. 7 to 5. Right? So we have 35 as the denominator or the total number of outcomes. Now let's go on to the numerator. The numerator is the tricky part over here. Number of desired outcomes. Now what is a desired outcome in this case? A desired outcome is when the sum of the 4 cards numbers is divisible by 4. See, that's what the question wants. So that will be termed as desired outcome. So I will just to demonstrate, I will be taking 4 numbers. Let's take 2, 5, 8 and 4. The first 4 numbers. 2, 4, 5 and 8. First, I want you to observe out of these 4 cards, which numbers are actually multiples of 4 or divisible by 4. This is and this is. These two are not divisible by 4. So let's look at the sum of this. The sum of this will be 12 plus 5, 17, 19. Is this divisible by 4? It's not. So this is not a favorable outcome. Now notice that it's not a favorable outcome only because of the presence of these two non-divisible numbers. On the other hand, if we had taken all 4 numbers as numbers which are divisible by 4, for example 4, 8, 12 and 16. 4, 8, 12 and 16 will give us, this will be 20, this will be 20, so 40. 40 is a desirable outcome. It's divisible by 4. So if you take any 4 cards that are all 4 of them are divisible by 4, then the outcome is favored. I'll be just taking another example to further demonstrate. 12, 16, 20 and 4. All 4 of these cards are actually divisible by 4. 36, 40, 52. Okay, so 52 is also divisible by 4. So you can notice a pattern. If all of the cards are divisible by 4, then it is a desirable outcome. On the other hand, if I had taken 2 instead, 2 is not a multiple of 4, it would have been 50, and 50 is not divisible by 4. It's 12.5. So we realize that the set has to contain cards that are only divisible by 4. We have 4, 8, 12, 16, 20. Now we'll have to choose 4 cards from this set of cards to have a favorable outcome or a desired outcome. So we have to choose 4 from 5 cards. We have narrowed down these 7 cards into 5 cards because only if I choose from this set, it will give us a desirable outcome. So we will have 5 combination 4. This will give us 5 into 4 factorial to 4 factorial into 1. So it will give us 5 itself. So we have 5 desirable outcomes. The number of outcomes is 5. So the probability will be 5 divided by 35. And this gives us 1 by 7. So the probability of getting a card, 4 cards whose sum is divisible by 4 is 1 by 7.